All right, guys. I want to first thank you all for who emailed me questions. Um, I do know that I have them and I worked them out for the ones that you asked. I also know that when you click on questions in the NoRe account, that it regenerates questions that are covering the same topic, but the problems may be a little bit different. So what I did was I went in and also looked at some questions just to see how they would be done. That way, if there's a variety of things that you guys are seeing, I could hope to address it when I address the same problem. So I was asked to go over number 10 from 8.4, number 15, or excuse me, number 14 from 8.5. I was asked to go over number 16 from 8.3, and I was asked to go over number 8 from our skills practice 7.3. So I have 4 questions that I was asked to cover with you. So I would like to do that and explain some things, maybe show you, if you haven't already seen it in the NoRe account, again, highlight some things that are in that pop-up menu. I don't know. I don't know if my screen is lagging. I'm not sure. So I will do my best to see how I can answer the questions, and then how do I solve that problem then? I have 10 people watching, but I am not sure how to alleviate that problem other than starting over. Hang on, guys. I'm not sure. Let's just refocus if we could, please. I apologize. I'm hoping that whatever's going on with the screen, it's alleviated itself. So I'm gonna get back to what we're looking at here. In this problem, I want to complete the similarity statement. That's our first thing that was in the NoRe account. In our account, it will tell you how to set this up. So the first thing that you have to look at when you plug this in is what triangle did they start with? So when we are looking at if they chose the first one to be called A, B, C, I need to know what is it going to be similar to. So I want to pay attention again to the letters that they are offering us. And again, we went in the order A, B, C. So I look back here at the tick mark that they've provided, but I also know that I have vertical angles that I can put tick marks in. So if they decided to go the given tick mark, no tick mark, and vertical angle, I need to go in the same order: the given tick mark, the no tick mark, and the vertical angle. So one of my answers has to be this, and it has to match. Now, the other answer, I have to find the value of x. So I'm going to use my similarity statement. That's the whole purpose of them asking for this, is I'm going to use this similarity statement so that I can set up my proportion. And I can see that AC, first and last, has been given to me. So our first question has been answered. The second question, first last, should match with first last. So EC and AC. So I can, if need be, list my proportion so that I know what to fill in. I can see 10 was given here, BC, and I can see that DC is in the same spot in the similarity statement. So we're going to then go with BC to DC. So now that I know what's supposed to match by using my similarity statement, I can, and you are correct, set up my proportion. So the whole purpose of them having the similarity statement there was so that I can set up my proportion accordingly. So AC is 8, EC is 6, BC is 10, and then I have X plus 1.5. And then we're going to cross multiply. So when we cross multiply, we are going to take 8 times that X plus 1.5, and then our 6 times 10. Distributing 8x plus 12 equals 60. We can subtract 12 from both sides, and we end up with 8x equals 48. And when we divide, we get x equals 6. So our second answer that we would have had to plug in is that one. Now for this question, hey Donnie, for this question, make sure that you just recognize that you're only solving for x. There's been a couple questions that I've gotten where we're not sure why we're getting it wrong and we're not plugging it back in. So just make sure that you recognize that we're solving for x, and the whole purpose of our similarity statement is supposed to be to help us get our proportion matched up correctly. So that one seemed to be, of all of them, the most straightforward. Not necessarily the easiest, but the most straightforward. Hey Jenna, it's good to actually see when people respond. I appreciate that. So let's go into number 14. And number 14 does require a bit of work, and a lot of it does come down to at least the questions I got about when number 14 was asked. I know that I'm supposed to do the angle bisector theorem, but there isn't anything here for me to know what the measurement is, and I can't subtract the way we looked at in class, so how do I find this? So we do want to go back to, and I liked that when this question came through, I had people saying, I know that we're supposed to have a length to use subtraction. Where is that coming from? So the biggest clue I can say is paying attention to, they put a right angle in there for a reason. So what that's telling me is they want us to concentrate on the fact that this very large triangle is a right triangle. So what we're going to do first is we're going to concentrate on finding that long length, that hypotenuse, by using our Pythagorean theorem. So we do have 6 squared plus 12 squared equals hk squared. So 36 plus 144 is going to equal hk squared, which means when I add them together, I end up with 180. Now we have to take the square root of both sides, and when we do so, you do not want to use a decimal. And that may be one of the issues that some of us are coming into, is that even though we talked about radicals and simplifying, we're still relying on those decimals, and we're not sure why we're not getting the answer correct, but we're never trying the radical. When I simplify this, again, if I have to, I can use scrap paper. The square root of 180 would be broken into 36 times 5. The square root of 36 is 6. And I know 5 has to stay there because it is a prime number. Hey, Jacob. So now that I've done the scrap work to figure out the square root of 180, I'm going to use that 6 radical 5. So we did our Pythagorean theorem, and we found that this entire length, all the way across, is 6 radical 5. And now, because I know this length, like we looked at on Friday, we're going to be able to do that subtraction. So think about it this way. If this was, let's say 16, I'd say 16 minus whatever this is, and I'd be able to find that measure. So I'm still going to use that information, except now we end up with 6 radical 5 minus x. So the hardest part here is just remembering that we're using a radical. So now I have, because it says PD bisects KDH, I know that I have this measure here and this measure here that should be equal, which does set us up to use our angle bisector theorem for proportions. So I'm going to work with bottom up, bottom up. So 6 to 12 should equal x over 6 radical 5 minus x. And again, we're back to our proportion. Mr. Hoffman, welcome. Cross multiply. We're going to take 6 times our 6 radical 5 minus x, and we're going to cross multiply and have 12x. When you distribute, don't forget, you only multiply the number in front of the radical. So 6 times 6, we end up with 36 radical 5 minus 6x equals 12x. We're going to go ahead and add 6x to both sides so that we can get all of our x's to the same side. And we end up with 36 radical 5 equals 18x. Solving for x, that's the only thing it wants us to do here. We're going to divide both sides by 18. And just like before, we're only going to worry about those numbers in front. When I check, 36 divided by 18 reduces to 2. So we end up with 2 radical 5 equals x. Now, if we go into our no-re assignment, what I can show you very quickly is down here, and this isn't necessarily the problem, but I do want to show you that if we have our answer to plug in, this is the part that I want us to pay attention to the most. I want us to be able to recognize that there is the square root symbol, that I do have our fraction button. So if I was to plug in 2 and then I needed radical 5, I would click on our radical and plug in 5. So I did a couple other questions, and I did a few that even had fractions as answers. And what ended up happening was I ended up with 3 radical 5 over 4. So the idea was I'd have to do 3 in my fraction. Notice I plugged in a fraction icon here, radical 5, and then was able to click in the denominator to put the 4. And that way I'd end up with the correct answer because it won't take decimals. So if you were wondering why something turned out the way it did, or you weren't able to get the right answer, you may have done everything correctly. You just had it as a decimal and not as a radical. And again, we've concentrated an awful lot on making sure we have those exact values. I will show you very quickly that I did another problem yesterday myself just to kind of see a variation of this. And it was another Pythagorean theorem question. And this is a horrible right triangle. But they did give us this right triangle where one of the legs was 3, one of them was 9. And you can see in order to figure out our the hypotenuse, 3 squared plus 9 squared ended up giving me 90. And our simplified was 3 radical 10. So if the whole side here was 3 radical 10, I was able to do the subtraction to find out this piece. And then I set up my proportion the exact same way. I went top to bottom, 3 to 9 equals D over 3 radical 10 minus D. I did the cross multiplication and the distribution all in the same step. So you can see 3 times 3 radical 10 is 9 radical 10. 3 times negative D is our minus 3D. And then I added 3D to both sides. And when I did the division here, I end up with D equals 9 radical 10 over 12. Again, the radical 10 isn't going to leave anything, but my 9 over 12 reduces, and I crammed it in over here, 3 radical 10 over 4. So 3 radical 10 all over 4 is what it would reduce to. Again, only worrying about those values that I am able to work with. So keep in mind that when we do plug them in, it's most likely going to have to be the radical unless they tell you to round. If you do not see round, we have always talked about the exact value is the one we want. So I know that sometimes I would allow the decimals, but we have concentrated on if there is square roots, please use square roots. Okay, so just know that when we are going over these, I will put all of this into Google Classroom so that if there's anything you want to take a closer look at, you can zoom in, you can take a look at even some of these extra problems that I've talked about. Up here, there was a question. I quickly jotted down the work just to see, and it ended up, it was, again, just like number 14. It was another variation, and I did the work there as well, kind of on that paper. So far, are there any questions before I go to the next one that I was asked to go over? Thank you, Miss J, for helping. We like seeing you join us. All right. Number 16 from 8-3 again was a question I was asked. The screenshot was taken. So again, if you tried it, you may have plugged it in wrong and they may have given you another question to come back to. So I again tried a couple different variations of this. One of the issues is please make sure that you recognize in this problem already, they don't want us to solve for x. They want us to use x and plug it back in and find the length of ms. So here in this question, pay attention that they are giving you the similarity statement on purpose. They want you to make sure that you're referencing what is supposed to match with what. So ultimately, and again, you're not going to probably do this every time, but what they want you to pay attention to is whatever the length of SR is, it's going to match with NG. And RA, the next two letters, match with GL. AM is going to match with LM. And SM, notice how SM is a side, is going to match with NM. So using our similarity statement, really what we're supposed to be understanding is that this proportionality statement could be useful. And in finding MS, this is what I want to rely on, which I only was able to determine because of that similarity statement. I don't want to use what I see because sometimes it doesn't match up. And when I tried a different question, I tried one that looked like this, but they were on top of each other. And our similarity statement that they gave me didn't match the way I thought the picture was drawn. So I really had to concentrate on that statement in order for me to know what went with where everything went. So I even wrote out my similarity statement and my proportionality statement to make sure I plugged everything in appropriately. So keep that in mind. That's the whole reason they gave that to us. So to make this a little easier on myself, I'm going to separate these two, again, just for visual purposes. And I'm going to put S, R, M, and A. That's our first quadrilateral. And the second quadrilateral that they told us to look at is N, G, L, and M. I can see that across the entire bottom piece here, we have 15. And from top to bottom here, I need to make sure that I add my 2 with the X that's there to get the entire length. So that's why this side is 2 plus X. And M, they tell me, is X, but I need to figure out what just ML is. Well, if this guy's 15, and let's pretend this was 8, wouldn't I take 15 minus 8 to find this piece right here? So I'm going to now call this 15 minus X plus 3. So this whole thing is 15 minus whatever that value is. So again, if I need to, my scrap work, 15 minus X plus 3, I can't forget that I'm not only subtracting X, but I am subtracting 3. So this is really 15 minus X minus 3. And 15 minus X minus 3 is 12 minus X. So again, if I have to, I have my scrap work that at least reassures me that I know that's what that value is. And now I have my corresponding pieces ready to fill in my proportion. So I can see that I have SM and NM, so I'm going to use this guy right here. MA and LM, I'm going to use this guy right here. So these are the two ratios I want. And I'm going to plug in their lengths to solve. So AM is 15. LM is 12 minus X. SM is 2 plus X. And NM is X. And we're going to cross multiply and solve. So when we cross multiply, I'm going to take 15 times X, and I'm going to set it equal to 12 minus X times 2 plus X. And here is where I have to remember my Algebra 1. We have to remember our FOIL method. We're going to take 12 times 2, and we end up with 24. We're going to take 12 times X, and we end up with plus 12x. We're going to go ahead and negative x times 2, which is minus 2x. And we're going to take negative x times x, and we end up with negative x squared. Remember, x times x is not 2x, it's x squared. And then we're going to make sure we combine our like terms. So these two guys we have to bring together, and we have 15x equals 24 plus 10x minus x squared. Now, as we finish this problem, I want to point out all the geometry was up until this point. Everything after that, after plugging it in, cross-multiplying, we're now into our algebra concepts. So this is a quadratic. The nice part about this quadratic is we don't need to worry about our quadratic formula. We just need to get everything to the same side. And we need to make sure that this cannot stay a negative x squared. So in order to move everything to one side, I'm going to add x squared to both sides. I'm going to subtract 10x, and we're going to subtract 24 to both sides. Lining up my equal sign, all of this is going to cancel. We want all quadratics to equal 0. And on this side, I now have a positive x squared. 15 minus 10 is now a positive 15x. And we don't have any other numbers to match up with minus 24, so we now just have our minus 24. And lots of ways to solve quadratics. Thankfully, the easiest way is by factoring. And we want to think this whole FOIL method again. What times what is negative 24? But adds up to 5. So, yep, you fixed it. Thanks, Elizabeth. So we want to make sure what times what is negative 24, but adds up to 5. So what are the two factors of negative 24 that if I add those numbers together will get me a positive 5 in the middle? I'll do the hard part. X times x is x squared. Does anybody know what two numbers are going to multiply together to get me negative 24, but add up to 5? What times what is negative 24, but if I add the two numbers together, I get a positive 5. Well, again, if I have to, I can look at what are the factors of 24. Yep, there we go. Thank you. If you have to, you could always do, negative 2 times 12, negative 3 times 8, negative 4 times 6, and then switch them. You could do that, but you are correct. Thank you for chiming in. We are going to want x plus 8, x minus 3. You could have had x minus 3 and x plus 8. Doesn't matter. Our zero product property, again, it's the rule that says after we factor, we take each of those quantities, set them equal to 0. We end up with x equals negative 8 and x equals a positive 3. Now, it's possible both work, but you need to check. So always make sure, check your answers. Does it make sense in the problem? And so if I go back and I look at what my lengths actually are in this example, I'm looking at -8 is impossible. I can't have a -8 length for something that's supposed to be a positive value. So right away, this guy isn't going to work, but I do know x equals 3 is what we're going to want to use. So x equals 3 is what we're going to want to use, but my answer is to find ms. So ms is 2 plus x, so we're going to take 2 plus 3, and we end up with ms is 5. So I do know that in some instances, again, we're solving for x perfectly. We just have to make sure that we read the question and that we are plugging in the value for x when it's asking for an actual length. Now, again, in wanting to see what some variations of this was, I showed you that I have done this problem a number of times. And I want you to take a look very quickly that I did a problem number 16, and it had two triangles that sat on top of each other. And when those two triangles sat on top of each other, they didn't match up the way I thought they were going to. So I had to pay attention to the similarity statement. And I did the same thing just to double check. That subtraction was still there, where we needed to make sure that we were subtracting a quantity to figure out what that length was. And just like you saw, I plugged it into TH and TN. Notice how one's over here and one's down here. So they're not side to side like we sometimes have seen. So TH and TN are here and here. So I plug them in. TK and TA are these two. Plugged those in. And then when I simplified, I did my cross multiplication. When I cross multiplied, I ended up with this fraction that, again, I went into our no-re assignment and went to figure out how do I plug that in. And again, when you're looking here, for instance, my number was 2, and then I'm able to access that fraction for 9/16. Again, that is not the answer to this question, but I am looking at how could I plug in a mixed number. So 2, and then our fraction, and then what's needed. So again, that wasn't this one's answer, but it was in fact how you would plug in the question that I was looking at. I tried it again with another problem, and this was kind of a work for a different problem, just to see how many times are we going to end up with mixed numbers. I cannot stress enough that this guy right here with our ABC button, or this fraction to decimal, decimal to fraction, or even now, again, thank goodness Miss J showed me this. I just always did it the way I was taught in elementary school. It can change mixed numbers to improper fractions and vice versa. So this right here, these two keys with our second button, helps tremendously when doing that work. So even something that looks like this, again, when I did this problem and it was kind of crazy, I just did -328 ABC instead of divided by -128, and notice it came up syntax error. Reason being is these negative signs won't work with the fraction. So that if I did, I'm hoping negative divided by a negative, I would remember is a positive. So you don't even need the negatives, 328, ABC 128, and it will give me that mixed number. If you did 328 divided by 128 and got the decimal, because I did plug that in and it didn't accept it, even though it was terminating, I just did second fraction to decimal, enter, and it gave me that mixed number. So keep in mind that that's something that does allow you to be able, oh, that's funny, I just saw that. Dabbing, well done, Miss J. Make sure that you do recognize that might be the issue. And I cannot stress enough that, yeah, in class, I might accept the decimal answers, but regardless of where we're looking to move forward in the future, whether it be ACTs or SATs, it's the exact value that we're working with, and that's what we have to be cautious to make sure we're still practicing. So that was number 16. Any questions or comments on that one? Again, all of this is getting uploaded to Google Classroom when we're finished. That way, again, if you want to look closer at something, you know that it will be there. This was the last question that was emailed to me that I want to make sure we go over, and it is one of your written assignments that I'm expecting from you. And you guys have done a wonderful job of emailing me your test corrections, any late work, and I have been now trying to get that back to you. Everything should be, as of just 15 minutes ago, updated. But make sure when we do hand in our work, you take those pictures, or if you have the capability of scanning them, send them to me and I will grade them. You do not have to wait until April 13th. You can send them in when you feel you are finished. So here's the last question that I was asked, and it wants us in our problems. Let's see if I can pull this guy up. It does want us to do the similarity statement as well as finding the length of VT. Now, I am going to try, oh good. In this, you can see I typed in some extra directions to remind you of what to do. It does say right here, identify the similarity, the similar triangles. By identifying it, that means write the similarity statement. Don't just look and think that everybody knows that you're looking at them. So identify the similarity, the similar triangles means write the similarity statement. Then it says find each measure. Right next to it, it says to find VT. So that's why when you're looking at what I've done is I've kind of split this up. And I'm going to look first at the fact that they're telling me that these are similar because they're asking me to do the similarity statement. So what I want to make sure of is that I look at these two parallel lines and I find that I have corresponding angles. Okay? And I know there's a little bit of lag right now. I'm not sure why. But I also know that I have reflexive. And I don't really need 3. I only need 2 in order to show me that I have 2 similar triangles. So I'm going to go ahead and I'm going to split these up. SRT with the tick marks that I've already put in. And then I'm going to redraw VUT with the tick marks so that I can keep track of everything. And that way, now what I'm able to do is write that similarity statement so that I know how to find VT. So I'm going to just play the matching game. 1, 2, bar. So S, R, T. And I'm going to do the same thing, V, U, T, going in the same order. So it is very important for those tick marks to be there. So now that I know what this guy is, again, in order to find VT, I could have done our proportionality statement. SR would go with VU, RT would go with UT, and ST, first and last, would go with VT, first and last. This is not required, but it does help. So when I come back here, I know how to match these guys up. So this one was 14 and that one was 6. VT is x plus 2, but ST all the way down is our 3x minus 3 plus the x plus 2. Which does mean, again, I've got to combine like terms to make sure that I know 3x and x would be 4x, minus 3 plus 2 would leave us with minus 1. So I just needed to make sure that I matched that up. Looking at this, I can see SR and VU are two of them that I'm given. I can see ST and VT are two of them that I'm given. So I just need these two in order to set up my proportion. So we're going to go ahead and take 14 over 6 equals 4x minus 1 over x plus 2. And we're going to cross multiply again. And after we cross multiply, we end up with 14x plus 28 equals 24x minus 6. I'm going to subtract 14x from both sides. And I end up with 28 equals 10x minus 6. I'm going to add 6 back. And I end up with 10x equals 34. Dividing both sides by 10, I end up with x equals 3.4. There is nothing wrong with fractions or decimals. Now in this case, if you've grown accustomed to writing this as a fraction, you could have 3 2/5. That's okay. You could have it as 3.4. Just depends on how you want, in this case, to just get kind of comfortable doing the same thing over and over again. X is not what we want. We want the length of VT. So I go back and I have to pay attention that the length of VT is thankfully just x plus 2. So I need to plug that in, and 3 2/5 plus 2 is going to be 5 2/5. So when we find the length of VT, 5 2/5, again, keeping it consistent with what we're doing as practice with the no reaccount. But if you did put 5.4, they're both the same. And because I'm grading it, I can take either. So make sure that we are paying attention to that. So, yeah, there is some lag. I'm sorry. Otherwise, Are there any other, I'm going to check my email to see if anybody sent me anything else. And I did not receive any other questions, but obviously the ones I did receive, I went over with you. If you have questions, please continue to ask and email them to me. What are we feeling like today? Any other questions? Please also keep in mind that everything is at Google Classroom. I never say it just here, and I spell everything out almost painfully in detail. So please keep that in mind, that you can always check Google Classroom for everything. Any other questions?